Our last section for this chapter deals with vapor pressures and boiling points. The boiling point of a substance is defined as when the vapor pressure of that substance is equal to the external air pressure. So if you think about what that kind of looks like, if you've got, say, a pot on the stove that's got water in it and you're boiling it, air pressure is going to push down on the surface of that liquid with a certain amount of pressure. This liquid is continually going to try to evaporate. And so as your liquid molecules get up close to the surface, if they have enough energy, they will escape as a vapor, as a gas. Okay, you can see that when you've got steam rising up off a cup of hot tea. You can see sometimes steam rising off of a lake. And so what's happening is that the molecules at the surface are rising up, and then they are going into the air. And when you get the temperature high enough, what happens is that you're going to start to form little bubbles down in here. And as these bubbles start to happen, there's pressure inside of them. And if the pressure of the vapor going up is equivalent to the air pressure that's pushing down, then we say that this liquid starts to boil. And you can see just all sorts of bubbles just happening all over the place. The higher the temperature, the higher the vapor pressure. And if you're also aware of how humidity works, if the temperature is really high outside, if you live in a tropical climate, or if you live in a more temperate climate where you've got seasons, you notice that you experience high humidity when the temperature is very high outside. If the temperature gets very, very low, sometimes we struggle with dry skin and a very, very dry air. The warmer the air, the more liquid it can hold. And so all of this is all kind of tied into the whole concept of vapor pressure. When we do experiments, we are often collecting a gas over a liquid. As an example, you've done experiments already where you put baking soda into vinegar. Vinegar is a solution of acetic acid that has been mixed in with water. So if you've got water in there, then the water, just like if you've got it on the stove, that water is going to be continually evaporating. Whether you're at the boiling point or not, the water is going to continually be evaporating. And so there's going to be gaseous particles up above the liquid there. So when you put if you're mixing your baking soda and your vinegar in a 2-liter bottle, and you take a balloon and you shove it over the top of the bottle, what happens is that since you've got water in there, you're collecting the carbon dioxide, but you're also going to have water molecules, water vapor molecules in there as well. So you have to take that into account when you're doing calculations, especially if you're looking for amounts. Okay, so there are charts available, and you've already seen one in your book, and there's a much more exact chart on the back cover of your book for a whole lot more temperatures than the one he gives you in the chapter of what vapor pressure is at a specific temperature, specifically for water is the one he's giving you because that's the one that we use the most often. So let's go ahead and do a sample problem that has all of these ideas included. A chemist produces hydrogen gas in an experiment and collects that gas in the presence of water. If the total pressure of gas collected was 1.115 atmospheres and the temperature was 26 degrees, what was the pressure of hydrogen gas collected? Okay, so what have I got here? I've got basically two gases present, and so I'm going to have a partial pressure of the water vapor that's there because I've collected the gas in the presence of water. So there is a partial pressure of water vapor. And then I'm also trying to find what the pressure of the hydrogen gas is. If you recall from before, once I know the pressure of the gas, if I know the temperature, if I know the volume of the gas, I can then calculate how many moles of that gas that I have. So that's why I would want to do this to start with. Okay. Now, I know that the total pressure of the gas is 1.115 atmospheres because they told me that. They also told me that the temperature was 26 degrees Celsius. So if you look on the back cover of your book, there is a chart right here that talks about the vapor pressure of water at various temperatures. And they tell you that at 26 degrees, the temperature of the pressure of the water is 25.2 torr. Well, if I know this pressure and this pressure, then it's pretty easy to find this one because they're just additive. However, these two guys are in different units, so the first thing that I'm going to have to do is I'm going to have to make sure that I have them both in the same units before I can do anything else. So if I take my number of torr and I want to convert it to atmospheres, in 1 atmosphere there are 760 torr. And so when I do that conversion, I have 0.0332 atmospheres for the water. And then the pressure of the hydrogen is just going to be simply 1.115 atmospheres minus 0.0332 atmospheres, which will give me 1.082 atmospheres for the partial pressure of the hydrogen. Okay, so additive effects here because of Dalton's law of partial pressures. Before we kind of wrap things up here, I just want to remind you, make sure that you have gone through and you've taken your index card and you've written down all the equations that you think you will need. Make sure that you go back through your problems. Have you written down all of them that you have used on your problems? Make sure that you have all those because that card will be very, very valuable to you when you take the test.